Morning, everybody. We're going to pivot from what we were learning last section and focus our attention on functions and relations today. So, a lot of this material is going to be a review from some of the things that we went over in Algebra 1 and in Algebra 2. So, hopefully, it starts to come back a little bit. So, we're going to start by talking about what a relation is versus what a function is. So, a relation is a set of points in the xy plane. It can just be one coordinate. It could be an infinite amount of coordinates. It is just some set amount of coordinates. Now, a function is a relation. It's a special kind of relation, though. It's a relation where the x value doesn't repeat. So where the x value isn't assigned to another y coordinate. It only has one y coordinate that it's assigned to. So, in general, there are two ways to determine whether something is a function or not. You can use the vertical line test that we'll look at here in a second, or you can use an algebra test, which we do here in a second. And so, for the vertical line test, all that you do is you look at your relation and you say, okay, for the vertical line test, can I draw a vertical line at any point through this and get a point where I cross twice? So like if I drew a vertical line here, it should only cross your relation at one point. And if it does, it is a function because this one x value only has one y value. So you could draw a vertical line anywhere on it, and if it only crosses in one point, then we say, okay, this is a function. So this would be a function right here. So then this what appears to be a cubic. If you draw vertical lines through this, or here, or here, they all cross, they all intersect at one point. So this would technically be a function. And also, I realize that I have not mentioned this yet. So the notes for today, I'm pulling these out of the orange book. So if you're someone who wants to follow along out of that book to copy notes down, you are perfectly fine to do that. I realized I forgot to mention that. It is example 1, page 48. So then we've got this sideways parabola here. And if we draw a vertical line through that, we see that it crosses twice. And so the thing is here, the reason this is not a function is because this point right here and this point right here both have the same x value, but they have different y values. And that is the definition of not being a function. So we would just say that this is just a relation. It is, we could say, or not, we could just say not a function. I'm going to write relation because every function is a relation, but not every relation is a function, or is not, or, excuse me, not every relation is a function, but every function is a relation. So that's the first way to determine it, is if you graph your function, that you can draw a vertical line through it, and if it crosses only once, it is a function. Now, the way that we're going to do the algebraic test is that we're going to solve for y. We're going to get y by itself, and we're going to see if x has multiple values from that. So when we look at this, we're going to be doing example 2 off of page 48. We're going to use some algebra to determine whether these relations are functions or not. So this first one that is solved for y, we've got y equals x squared minus 9. And regardless of whatever we pick for x, it's going to give us a y value. There's no place where we could have multiple x's here. So this would meet the criteria for it. This is actually a quadratic has a highest exponent of 2. Its graph would be a parabola, and it would indeed be a function. Now, this next one right here, this is not solve for y. So what I'm going to do is solve for y real quick. So I'm going to subtract x over. So I would get y equals negative x plus 9 if I subtract that x over. And again here, we're not in a situation where we have like multiple x values. Like if you graph this equation right here, it's actually just going to be a linear function. And we would say, oh, okay, yeah, sure, that is a function. You can only draw a vertical line through it. Now, to make it a little bit clearer here, though, so on this last one where we're saying use algebraic methods to decide whether these relations are functions, we've got to solve for y real quick. So if we subtract x squared over, we'd get y squared equals negative x squared plus 9. And we still haven't solved for y because we have y squared. So to solve for y, we're going to take the square root of both sides. And what that's going to do is when we're creating this graph, we're going to get plus or minus negative x squared plus 9. And the act of taking that square root, of creating that plus minus right there, that is going to give us 2 x values. So x is going to have multiple values here now because of that positive negative that we created when we took the square root of it. And because of that, it's not going to pass a test to become a function. The algebraic test where we got 2 x's that are created from taking that square root is going to be no. There are multiple x values for y. And if you actually graph this original one, you can do that on Desmos. It's actually the graph of a circle, and a circle will never pass the vertical line test. So then that's a start on relations and functions there. So the next thing that we're going to look at is we're going to look at some function notation here. So one of the things that we need to understand here is that f of x here is basically just saying the image of x. And that if you see f of x, that means the exact same thing as y. If you see f of x, you just need to assume that that means y. So some math shorthand here is, so whenever you're writing a function, the way you read this is f of x, or a function of x, equals 2x squared minus 3x. And we want to find the value of the following two expressions. So kind of the way that I've always looked at this is, if I want to find f of 5, well, what did we replace x with? We replaced it with that 5 right there. So we're going to replace every x here with those 5s. So we'll say f of 5 equals 2. I'm going to put parentheses. Hopefully this different color shows up just a little bit. I don't know why I put x. 5 squared minus 3 times 5. And we're going to evaluate this. So 5 squared is 25 times 2 is 50. We get f of 5 equals 50 minus 15. F of 5 equals 35. And we would just, so the way that you would represent this with a coordinate would just be 5, 35 if we were going to attempt to graph this thing. So 5, 35 says the exact same thing as f of 5 equals 35. So then when we, let's do another one real quick for -4. If you want to pause it and do this one yourself, you are more than welcome to. Just some quick computational math here. So let's see, 2 times to the negative 4. That's getting squared, minus 3 times negative 4 here. So let's see, negative 4 squared is 16 times 2 is 32. That's going to be plus 12 there. So then f of negative 4 is going to be 44, and we can best represent that with the ordered pair negative 4, comma 44. Just to keep that in mind. Now, whenever we're evaluating functions, you are allowed to substitute things into functions that are not numbers. So, for example, if we wanted to substitute in f of negative x, all that this means right here is that we're going to replace every x with a negative x. That good old function notation there. So if we solve for f of negative x here, that's going to be 5 minus, where that x is, we're going to put a negative x, minus negative x squared. Now, you just got to be careful not to mess up the order that we evaluate in. We need to start with the exponent here. So negative x times negative x, it's getting squared, is just going to be a positive x squared. So then we've got f of negative x equals 5. Negative times a negative x is going to be a plus x. And then this is going to be minus x squared. And I guess you don't really need those parentheses there. I guess you don't need them. And just for my sake, I'm going to put these in order from the highest exponent to the lowest exponent. That's proper notation. Just to have it in standard form, highest to lowest. So that's the simplified form right there. So then we're going to do 2 more examples. We're going to do one with x plus 2, and we're going to do one with x minus 1, and then subtract 5 from that. So if you want to pause this and see if you can knock this out, you are more than welcome to. Let's see here. So if we're going to substitute x plus 2 into here, 5 isn't going to change. Where that first x is, I'm going to put parentheses x plus 2. That's what's getting substituted in there. Minus x squared, so we're going to minus x plus 2 squared. Now, the biggest thing here that I've noticed just from teaching Algebra 2 most years is what students will try to do. I'm going to go ahead and change that to minus, I don't know, this is getting messy, minus x minus 2. The biggest thing that students will try to do is just say, okay, well, this is x plus 2 squared. That's going to be x squared. Just distribute the squared, Mr. Price. But you got to remember that this is saying x plus 2 times x plus 2. There's 2 of those things there, and we've got to distribute those. So when we do x times x, that's going to give us x squared. Plus 2 gives us 2x, plus 2x, plus 4. That's still the minus sign chilling out there. So we've got 5 minus x minus 2. We'll change the signs on all that stuff here in a second. So minus x squared, I'm going to combine those and then change the sign. Minus 4x minus 4. And then we will just finish combining like terms. So f of x plus 2 is equal to negative x squared minus 5x and then minus 1. So then the last thing that we're going to look at is we're going to evaluate it. So we're going to substitute an x minus 1 into f, and then we are going to subtract 5 from it. Give me 1 second, everybody. I think my setup for this phone needs to be fixed real quick. All right, I think that we're good now. So if we're going to evaluate this, the first thing we need to do is substitute in x minus 1 into everything. So let's see. We got 5 minus x minus 1 minus x minus 1 squared. And then at the end of all that, we'll have a minus 5. So right off the bat, I'm going to go ahead and cancel these minus 5s. Because it's like 5 and minus 5. Those are going to cancel out. So then as we'll see, f of x minus 1 minus 5 equals. So then this negative, if we distribute that, gives us negative x plus 1. Again, we need to write out both of these terms here. So negative, we've got x minus 1 times x minus 1. And if we distribute there, that's going to give me x squared minus 2x plus 1. I'm just going to shortcut that one because I am running out of room. Let's see, f of x minus 1 minus 5. So then that's going to give us negative x squared plus 2x minus 1, negative x plus 1. I apologize that I'm doing all of this kind of out of order. That's just kind of the way that my brain works when I'm doing algebra. So then negative x and 2x is going to give me a plus x, and then 1 and minus 1 is going to cancel out. So then f of x minus 1 minus 5 equals negative x squared plus x. So that is today's lesson. If you all have any questions on any of the content, you are welcome to stop by in Zoom. I will have your homework assignment posted on Canvas, and so if you all have any questions, please let me know. Thanks.